What we're going to do today is compare the difference between an equation and an inequation. The biggest thing to notice right away is that this has an equal sign in it. This one has less than or equals to, which means that it's more than just one solution. The rules of equations are all the same. Expand everything out, get 1x at the very bottom. So I'm going to multiply the negative 2 into the bracket, both terms, negative 12 minus 2x. The right side, nothing changes. Expand, now I'm going to collect the like terms. On the left, 5x minus 2x. On the right, 3 plus 8x. Don't forget to line up your equal signs. At this point I have to make a choice. Which side do I want to put the x's to? Well, pretend that I don't really think ahead too far. I'm just going to bring the letters to the left, as we tend to do a lot of the time. And that means that 8 is going to come across as a negative, because it goes across the barrier, the equal sign, makes it opposite on the other side. And the negative 12 is going to come over to be a positive 12 on the right. Simplify the left, simplify the right. Remember, I want to know what 1x is, so I'm going to divide through by the coefficient, in this case, negative 5. Reduce, works out evenly. X is equal to negative 3. One solution to the problem. When I get to the inequation, you've got to realize now all of the same rules apply, except this inequality symbol is going to require one extra little detail to pay attention to when we divide by a negative, and at the end we're going to get more than one solution. So, just like before, I'm going to expand the bracket, carry through the negative 6x, multiply the 5 into both terms of the bracket. Whole slew of numbers. Well, I'll try the same thing as before, just collect the like terms on the left, so negative 4x minus 16 less than or equal to 5x minus 25. And just like before, I'm going to bring the letters to the left. So the negative 4x minus 5x and negative 25 plus 16. Let's keep the balance. Okay, it went across. On the left, I'm going to get negative 9x. On the right, negative 9. Now here's where we've got to be careful. If it's an inequality and you divide through by a negative, you have to reverse the direction of the inequality symbol. In other words, divide by negative 9, both sides, and we're going to circle this, because in the next line we're going to turn that around. X, positive x, greater than or equal to positive 1. We have to reverse that inequality because we're dividing a negative both sides. If I had 4 less than 12, and I divided both sides by negative 1, that would say negative 4 is less than negative 12, which isn't true. That's why you have to reverse it when you divide by a negative. So, there's my solution. Well, I should say these are my solutions, because this is saying that on a number line, everything from 1 up to infinity. Or if I wanted an interval notation for this, x goes from 1 to positive infinity this way. Now I don't really like the way I ended this off, because I hate dividing by a negative. I know I'm going to make mistakes. You're probably going to make mistakes too. You're going to forget to reverse that inequality. So backing up to this step, let's take a look at the alternate ending. Instead of taking the letters to the left, I'm going to take the letters to the right. So the negative 16 is going to remain on this side. Negative 25 is going to come over to the left. It's going to be positive. 5x stays on the right, and the negative 4x is going to go over as positive 4x onto the right. Now I get 9 less than or equal to 9x. Notice, same situation except that the letter is on the right hand side, and both of these terms are now positive. So I don't have to think about dividing by a negative, I just divide by the positive 9. And this gives me, on the right, just x, and on the left, 1. Now, I'm not going to read this as 1 less than or equal to x. That doesn't flow nicely. You want to read it from the letter. X greater than or equal to 1. And just like before, this refers to the solutions. Value is 1, and all of the numbers greater than, x is greater than 1. Interval notation is the same. It's going to go from positive 1 to positive infinity. Now, I've made one assumption here, and that is that I'm talking about real numbers. If I was saying that x comes from the integers, then my solution wouldn't be that whole continuous line. It would be a series of dots, 2, 3, 4, 5, 6, dot, 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 going all the way to the right. And I'm not allowed to put interval notation for integers. Have to list it as a solution set, 1, 2, 3, and so on. Thanks, and hope this helps.